Okay, we're gonna wrap up with a proof and then a little bit of application of similar triangles to trigonometry. So you get a little bit of trig fun in this, and what we do in trig at the end will actually help you with the bonus that I put on the homework. But the very first thing we're going to look at is a proof, again involving triangle similarity. You don't see that initially when you look at this, but I'm telling you it's going to come into play. You're given that angle C and DA are right triangles, and they're identified with a 90-degree angle. You want to prove that AD times BC equals AB times DE, and you might initially feel like, what? Where is that coming from? How am I going to prove that? But I want you to look back at some of the handouts that you had. One of those handouts is the one that has the triangle congruence and similarity. And on the back, you will notice that it says, corresponding sides are all in the same proportion. We want to prove a product, but does not a product like that come from cross multiplication of a proportion? Specifically this, AD belongs to this guy, and it would correspond with AB, right? So if you pulled this one down here, the AB, you would have AD over AB, because those two correspond. So this side corresponds with this long side, because I'd swing this around to put, I'm going to actually draw it. This would be the smaller 90-degree triangle. This would be ADE. Here's where the right angle goes. So AD corresponds with AB. And then you would also then want to do what? You'd want to bring BC down here and put DE, which is this side on the top. That's that bottom, that base right there. That corresponds to what? To BC. So if you can prove that this smaller triangle is similar to the bigger one, which we should be able to do because we already know that they both have this angle in common. What other angle do they both have in common? A, yes. If you can prove they're similar, then you can prove that you could show that their sides are proportional, because that's a property that naturally follows. Corresponding sides are all in the same proportion. Then if you move to this sheet, the very last property on here is the cross product property. In a proportion, equality holds when the denominators are cross multiply. There you go. You've outlined the proof. You've worked backwards through the model that you had to figure out what you need to do. That is critical to students writing proofs. They have to move from the end back up in a logical sequence. What helps to do that? Math discourse with a partner. So I highly encourage you, talk with others, encourage your students to talk with others. But let's go ahead and write this proof out formally. So we have our given, which is angle C and angle DEA are right angles. That's by good old given. Number 2. Now, you might say, why do I need to do this? But now we're going to say angle C is congruent to angle DEA. You're probably like, I just said they're both right angles. Isn't it implied? So, not necessarily. You're going to look on that handout and you're going to see that there's a property that is just right angles are congruent. So they might both be right. If you say that, great, but then what follows from them is the property that right angles are congruent. If you forgot to do that in a proof, would I take off much? No, I'm talking like a point, because I understand that that's something easy to forget, but now that you've seen it, you know you need to do it. So right angles are congruent. Okay, that's the next property. Okay, then we already said that A is equal to A by reflexive property. So now what can we say? We can say that triangle AED is similar to triangle ACB. Again, making sure that you have corresponding parts, corresponding angles written in the correct order, and that's by good old angle. Then you can say that their sides are proportional, specifically the sides we care about. AD is over AB is equal to DE over BC. And you could write that at just using this. Corresponding sides are all in the same proportion in similar triangles. It's also written, well, that would actually probably be the best way to put it. So corresponding sides of, and I'm just going to put the little similar sign of similar triangles, are all in the same proportion. And then the last thing would be cross multiplying them. So AD times BC will equal AB times DE. And you could do one or two things. You could put just cross product property. That's fine with me. Or you could write it out. There's so many different ways. It's just applying them correctly. I don't mind if you just write the property name or if you write it out, but we've already looked at it on the handout so you know what it means. Okay, the next part. We talk a little bit about trig here. I'm gonna actually pause this and start a new video. That way they're short and I can upload them a little faster to YouTube.